related to question 4. There's A, B, C, and D. So let's look at this. It says in figure 4 below, so here's figure 4. Figure 4. A graph shows the relationship between mass and volume for two substances, A, which is over here, and B, which is over here. In addition to water, here's water. Cool. So just making sure you got that. Use the graph to answer questions about these two substances. So let's look at A. You have built a simple two-pan balance shown above to compare the masses of substance A and B. Now, to remind you, if you aren't familiar with a balance measures weight or mass. If A had a larger mass than B, I'm just going to say mass. If the mass of A was greater than the mass of B, then it would tilt towards A. If the mass of B was greater than the mass of A, then it would tilt towards B. If they are equal in mass, so if A and B are equal, it would not move. So keep that in mind. If my mass of A was greater than B, it would tilt this way. But if my mass of B was larger than my mass of A, it would tilt this way. If they're equal in mass, it will not move. So let's answer this question now. What would happen to the balance if you put equal masses of A and B in the two pans? Equal masses, nothing will happen. Nothing will move. But now the second question, what happens if you put equal volumes of A and B? Now this is tough. We're going to need the graph to look at this, and we've done this in our notes. Let's identify a volume. Let's just do 20. We could predict and look at the graph and identify what masses substances A and B would be using its volume. We could draw a vertical line going up here. At 20 milliliters, it looks like the mass of B would be about 10 grams. But at 20 milliliters, it looks like the mass of A would be about 30 grams. So if it was equal volumes would tip towards A. Why? Because if it had the same volume, A would have more mass than any given volume. Tip towards A because it has more mass in a given volume. And that would work later. What if we did 50 milliliters? It looks like 50 milliliters of substance A would be about 80 grams. And it looks like 50 milliliters of substance B would be about 25 grams. So that will be true for all masses versus volumes of A versus B. Now let's look at question B here. It says, if you put 10 milliliters of A in one balance pan, what mass of B would you need in order for the pan to make it balance? Remember, in order to make it balance, we need equal masses. So we need to figure out, really this question is, what is the mass of 10 milliliters of A? This really is what this question is asking for. I'm going to look back at this graph here to kind of help us out. We could predict that using the graph. So I'm going to delete that. Whoops, trying to delete things here. Delete. So let's look at 10 milliliters of A. Here's 10 milliliters right here. Not to confuse it with the 20. I'm going to draw a vertical line going up. I'm trying to make it a little bit neater. So if I draw a vertical line going up, wherever it touches on the graph is going to be the mass of A. So B is right here. A is up here. It looks like the mass of A is approximately 15 grams. So 10 milliliters of A is approximately 15 grams according to the graph. Do you see that? I'll highlight it if you couldn't see that. Right here, 10 milliliters is about 15 grams of A. Now, in order for the pan to be balanced, we will need 15 grams of B. We need equal masses, just like this question up here. If I had equal masses, it will not move, it will be balanced. So that's our answer for letter B here. All right, let's do C. If you put 35 milliliters of B in one balance pan, so I have 35 milliliters of B, I'm gonna go back to my graph here. I'm gonna erase some things to help us out so we could see the graph clearly. I'm gonna erase some things so I could do all this fun stuff. Boop. Because we're gonna do 35 milliliters on this graph here. So let's see, if you had 35 milliliters of B, where's B? B is right here. 35 would be right here. Its mass would be like right here. If you had 35 milliliters of B, what volume of A would you need? Now this is tough. This is going from one substance to another. So if I have 35 milliliters of B, according to the graph, that would be about, I'm gonna estimate, maybe about 17 grams of B, according to the graph. So if I estimate I have about 17 grams of B from 35 milliliters of B, and then it says what volume of A. Well, in order for the pan to be balanced, I would need to be balanced. I would also need 17 grams of A. I kind of already have it labeled off here. If I have 17 grams of A, where does it hit on its graph, and what volume would that be? Well, the graph is right here. This is 17 grams of A. It looks like its volume is about 10 milliliters of A. So that represents 10 milliliters of A. So that would be the answer. I did that all using the graph and finding those approximate data points. So that is how you answer letter C. In order for the pan to be balanced, we need equal masses. This question's asking for what volume would give us those equal masses, and that would be 10 milliliters. For fun, I'm gonna make sure that we could see the slopes of A and B. Clearly you could see that A has a larger slope. The slope of A is approximately, I'm gonna estimate, it's like 80 divided by 50. The slope of A is 1.6 grams per milliliter. That's its density. The slope of B, you can kind of see it's half. That's 0.5 grams per milliliter. If I took like a 40 milliliters, that would be 20 grams. That's 0.5 milliliters. So we could clearly see that the density of A is larger than the density of B, and it will always have more mass than a given volume, and I would need less volume to have equal masses. All right, letter D here. Water has a density of 1 gram, and that's shown by the blue line there in figure 4. Determine whether substance A and B will sink or float when placed in the bucket. Well, from our notes, if the density is greater than water, it will sink. If it's not, it will float. So we could clearly see that the density of A is greater than water. A will sink. But B its density is less than water, it will float. And so it says to then your answer, the density, aka the slope, of A is greater than water, but the density of B is less than water. And that explains why A will sink and B will float. So that was question